Let us look at the next section, students. This section contains 5 questions. Each question has 4 options, out of which one or more than one option may be correct. So let's start with question number 26. Assume that Pauli's exclusion principle can permit 3 electrons per atomic orbital or molecular orbital rather than 2 electrons. On the basis of this information, select the molecules which have bond order equal to 2 by 3. So we have to assume that sp mixing is operative and one covalent bond shares 3 electrons only. So students, what is going to happen now is that the bond order shall be equal to number of bonding electrons minus number of anti-bonding electrons upon 3. So we have to use this 3 as it is given to us that one covalent bond shares 3 electrons. Now if we talk about the species which are given to us, we have H2. So H2 has a total of 2 electrons. Next we have He2. He2 is going to have 4 electrons. Next we have N2. N2 is going to have 14 electrons. And we have B2 finally. So B2 is going to have 10 electrons. We can probably write the molecular orbital configuration for each of them. So we have H2. So we'll have sigma 1s2. If we talk about He2, we're going to have sigma 1s3, sigma star 1s1. If we talk about N2, the configuration of N2 will be sigma 1s3, sigma star 1s3, sigma 2s3, sigma star 2s3. We're going to have sp mixing operative in N2. So next we'll have pi 2px1 equal to pi 2py1. And lastly we have B2. So we can write the configuration for B2 as well. We're going to have sigma 1s3, sigma star 1s3, sigma 2s3 and sigma star 2s1. So if we talk about the difference in the number of bonding and anti-bonding electrons, we're going to have a value of 2 in this case, and upon dividing it by 3 we're going to have a bond order of 2 by 3. If you talk about He2, in He2 again we have a difference of 2 electrons, so this is also going to have a bond order of 2 by 3. If we talk about N2 now, these electrons are going to cancel each other out. We have an excess of 2 electrons in the bonding orbitals, so this is also going to have a bond order of 2 by 3. And if we talk about the last one, this will cancel each other out and there will be a difference of 2 electrons which are excess in the bonding orbital in this case also. So this is also going to have a bond order of 2 by 3. So if we look at the options which are given to us, we can clearly see that we have to select all 4 of these options as the correct answer to this question. Let us look at question number 27 now. The basic strength of the following amines is measured in water and benzene. So we have been given methylamine, dimethylamine and trimethylamine. We have to select the correct statements. We can probably first talk about the basic strength of these given amines in these solvents and then we can look at the options. So if we talk about the solvent water, so in water hydrogen bonding will take place and due to that the basicity order will be affected. So if we talk about water, we know that the basicity order follows the order dimethylamine is more than methylamine is more than trimethylamine. And if we talk about non-polar solvents like benzene, where there is no effect of hydrogen bonding or solvation, here only inductive effect dominates and greater the inductive effect, greater is the basic strength of the amine. So here we are going to have an order of 3 more than 2 more than 1. So if you look at the options now, in option A it says basic strength of 2 is greatest among 1, 2 and 3 in water. This is correct, students. The first statement is correct. Let us look at statement B now. The basic strength of 3 is greatest among 1, 2 and 3 in benzene. This is also correct, students. If we talk about the statement C now, basic strength of 2 is more than 1 in both the solvents. We can see that the basic strength of 2 is more than 1 in both the solvents. This statement is also correct. And if we talk about the last statement which is given to us, basic strength of 2 is more than 3 in both solvents. This statement is incorrect, students. In benzene, which is the non-polar solvent, the basic strength of the trimethyl derivative is greater than the dimethyl derivative. So for this question, we have to select the correct statements and we have to mark option A, B and C as the correct answer to this question. Let us look at the next question now. Let us look at question number 28 now. Pb3O4 is a mixed oxide in which lead is present in a state of +2 and +4 oxidation states. Select the correct statements. So the examiner seems to be interested in the reaction of Pb3O4 with HCl and HNO3. So let us first talk about this Pb3O4. So Pb3O4 is a mixed oxide. It consists of PbO and PbO2. Now if we talk about lead, we know that the most stable oxidation state of lead is +2. So +2 is greater than +4 as far as the stability is concerned. Now it is mentioned to us that this Pb3O4 is allowed to react with HCl. Now what happens is, if we talk about HCl, so in HCl, Cl is present in the form of Cl minus. So this Cl minus can lose electrons, and this lead, which is present in a state of +4 in PbO2, is not very stable. So what will happen is, this PbO2 will accept electrons from Cl. So PbO2 plus Cl minus, it is going to form PbCl2. So the lead will be converted into +2. It will gain electrons which are donated by Cl minus ions, and the Cl will itself convert into Cl2. So in which it has an oxidation state of 0. So the reaction of Pb3O4 with HCl, it is a redox reaction. So let us look at the options which are given to us regarding the reaction with HCl. So it says that Pb3O4 reacts with HCl and undergoes redox reaction. This statement is correct, students. If we talk about the second option now, Pb3O4 on reaction with HCl form Cl2 gas. So this statement is also correct, students. We've seen that chloride ions lose electrons and convert themselves into chlorine gas. Let us now talk about the reaction with HNO3. Now we know that HNO3 is an oxidizing agent, but lead, which is present in form of PbO and PbO2. So lead +2 is already very stable, so it will not be oxidized into lead +4. It does not like to go in a state of +4 as it is not very stable due to inert pair effect. So what is going to happen is, this HNO3 plus PbO, there will be no redox reaction happening in between them. So option D is incorrect. Now we can talk about PbO. PbO, we know that it is amphoteric. So it can react with both acid as well as bases. So it will react with HNO3, it will show the basic nature, and it will convert into lead nitrate. So that is the only reaction which is going to happen in this case. So students, if you look at the C statement now, the statement given in option C is correct. So for this question, we have to select the correct statements and we have to mark option A, B and C as the correct answer to this question. Let us look at question number 29 now. A weak acid H3A has 3 dissociation constants as. So the value have been given to us. It's 10 to the power -4, 10 to the power -8 and 10 to the power -16. If metal ion M3 plus forms a sparingly soluble salt Ma with KSP equal to 10 to the power -30 in water, and metal form MCl3 that is completely soluble, select the correct statements if concentration of H3A is 1 molar. So we have to ignore the hydrolysis. Okay. So we start with the options A and B. So in option A and B, the examiner is interested in the pH of the solution before the addition of MCl3. So we had 1 molar H3A, and looking at the Ka values, we can see that Ka1 is very much greater than Ka2, which is very much greater than Ka3. So we can safely assume that almost all the H plus in the solution will be coming from the first dissociation of H3A. So we're going to have H3A converting into H plus and H2A minus. So if we talk about the K value, the K is given to us as equal to 10 to the power -4. Now we can have T equal to 0, in which H3A was 1 molar. At T equilibrium, we'll have 1 minus X, X and X. And we know that this X can be neglected with respect to 1. So if we solve for this K value, so we're going to have X square upon 1 equal to 10 to the power -4. So the value of X is equal to 10 to the power -2. So the X here equals the H plus ion concentration. So from this we are going to have a pH value equal to 2. So out of given statements A and B, we can see that the statement A is correct, whereas the statement B is not. The pH is not equal to 4, the pH is equal to 2. Let's look at the C and the D options now. If excess of MCl3 is added in 1 molar H3A, the degree of dissociation of H3A increases. So if we talk about this MCl3, it is given to us that MCl3 is completely soluble, which means that there is going to be M3 plus ions present in the system. Now, when this M3 plus ions are allowed to react with A3 minus ions, they'll quickly form Ma and it will form a precipitate. So what happens is the A3 minus ions will start getting consumed from the solution, which will lead to this equilibrium shifting forward. Now when this shift forwards, the other two equilibriums will also shift forward due to consumption of the product. So we can say that the degree of dissociation of H3A has increased. So students, the statement given in option C is correct. Due to addition of excess MCl3, the degree of dissociation of H3A will increase due to the consumption of the A3 minus ions, which will drive all the other equilibriums in the forward direction. If we look at the D option now, if excess of MCl3 is added in 1 molar H3A, the pH of the solution increases. So this statement is incorrect, students. Due to addition of MCl3, we had seen that all of these equilibriums will shift in the forward direction, which will lead to a increase in the concentration of H plus ions, which will further decrease the pH. So students, we can see that we have to select option A and option C as the correct answer to this question. Let us look at the next question, question number 30. One of the most remarkable features of the alkali metals is their solubility in liquid ammonia to give metastable solutions with unusual properties. Select the correct statement about this solution. Students, if we talk about the dissolution of alkali metals in ammonia, so we know that alkali metals, when they are dissolved in liquid ammonia, they lose electrons to form cations, and these cations are ammoniated. And also the electrons will also get ammoniated. Now what happens is this unpaired electrons present in the solution, it gives paramagnetic property to the solution, due to which it exhibits color. So the solution is blue color when it's dilute. Now if we increase the concentration, due to increment of concentration, these electrons, they start pairing up and then the paramagnetism decreases. So as concentration increases, pairing up of electrons happens. And paramagnetism decreases. And the color is converted into bronze color. So if you look at the options which are given to us, option A says that the solution has blue color when it's dilute. This statement is correct, students. If you look at the B option now, conductivity of dilute solution is greater than concentrated solution. This statement is also correct, students. When the concentration is increased, there is pairing up of electrons, and due to this pairing of electrons, there is lessening in the number of charge carriers and the conductivity is decreased when the concentration of electrons is increased. So this statement is also correct. If you look at the C statement now, solution becomes bronze colored at higher concentration. This statement is also correct, students. And looking at the last option, dilute solutions are paramagnetic. This is also correct, students. Due to this paramagnetism, there is color observed in the solution. So we can see that all four of these statements are correct and we have to select all of these as the correct answer to our question. Let us look at the next section.